Hello everyone, welcome to Binary Broom. Well, this time we are going to talk about factory method, also known as virtual constructor. It is one of the patterns in creational patterns, which is the subset of design patterns. Well, let me start with the problem. Well, it says that imagine that you are having a logistic management application that handles all the transportation by trucks. But you also have a lot of requests to do the sea transportation uh, using ships. Well, your whole code is tightly coupled with the truck class, and everything is written using this truck class. And adding ships into your application will require you to make a lot of changes all over your code, and that's a huge price, and it's gonna take a lot of energy and time. But on the other hand, if you are going to add another type of transportation, like using a plane, that's going to require you to make the same changes again and again. So what's the solution here? How are we going to make these changes into our code base in a way that adding more types of transportation doesn't require us to make a lot of changes in our code? Well, the solution is to make an abstract class. We can make a new class that is kind of an abstract class, the parent of those two classes that we are going to have. This abstract class is going to have a create transport method, something like that. That's going to work as our factory. Here we're going to create our objects, and the return type of this method is going to be logistics type. So we have two subclasses, road logistics and sea logistics, but the return type of this create transport is going to be the general one, which is a transport. So some transport is going to be returned, but the it being the road logistics or sea is going to define the future methods that are going to be executed. So we have a abstract class that's gonna work as our interface. It's gonna declare some functions or variables inside the class. Also, some common implementations that are the same in our C logistics and road logistics, and the different parts are gonna be implemented in each class separately, and inside each method could be implemented and written in the subclasses totally separately. And you when you call, I don't know, like the deliver method, this the what's going to be executed inside this method is gonna be totally dependent on the implementation on the subclass. So if you don't implement it in your abstract class, it's gonna totally look into the implementation of your subclass, and it's gonna execute that one. So the inside of each method could be different depending on the type of transport that you are using. So that's the solution that we have. We're gonna create an interface which is called transport, and we're gonna have two types. And when we call deliver, it's gonna have different implementation for each truck or ship uh, transport, and it's gonna do two different things. But since there are in two subclasses, we have an abstract class. So if we want to add another way of transport like plane, we don't have much effort, so we can just put another class, another implementation here, and another type of delivery will be added to our code with the least amount of effort and energy. So that's how it's gonna work. It has an explanation of the whole structure here as well. So we have a creator that's gonna create our objects, and the different implementation of each method could be written in those subclasses. But the return type should be as the abstract class name. so that in your code it doesn't make any difference. So for example, here you are working with a product object, so it doesn't matter in your code that what subclass it is using. It's a product object, and it's gonna have a, I don't know, a do stuff method, and when you call it, it's gonna execute that do stuff depending on what subclass it belongs to. And also here there is a pseudocode, which I'm not gonna get into it. It's quite clear. You can check it out on the website. And here we are going to see the applicability. So where can we use this? Well, use the factory method when you don't know beforehand the exact types and the dependencies of the objects your code should work with. So when we are making a class that we don't know if we are going to do things differently in the future, or we are going to add another type of doing that job in the future, we can use an abstract class that creates our objects and defines the entire interface. And then when we want to add a different type to our code, it's gonna be quite easy. We just have to declare the class and make it a subclass of the parent and abstract class that we have already, which has the interface, the general common codes, the method declarations, and you just have to fill into the methods depending on the type that you added, the way it handles stuff. That's one thing. Also, when you want to provide users for your library and framework to extend the internal components, here it explains an example of this. For example, imagine that you're using the framework that only provide square buttons, but you want round ones. So how are you going to do it? You're gonna make a standard button class that's actually you're going to make a round button class, which is a subclass of that button that that framework has. Then you're gonna implement the methods inside it depending on what you want in a round button. Then you're gonna make a UI framework use this round button. So you need another class which is UI with round buttons. It's gonna be a subclass of UI framework. Then inside this UI with round buttons, you're gonna return round button. But since the general type of round button is still a button, you don't have to change anything in your code. So because your code is working with buttons, and round button is a type of button, so it doesn't need to make any changes. It calls this certain methods, and the only difference here is that the implementation of those methods is going to be different. Another way to use this is when you want to save systems resources by reusing existing objects instead of rebuilding them each time. Well, here you're gonna need a pool. You're gonna choose whether to use the objects that are already there or create a new ones. Well, the more explanations are there, and how to implement is quite simple. You need a same interface across all the classes. You need an empty factory method inside the creator class, and you're gonna have to return the same type inside the creator, and your code needs to work with that abstract type, and so on. It's quite simple. And the pros and cons in this method is that when you use this method, your code is not coupled at all, so you are avoiding tight coupling, so it is a lot easy to add more stuff, and your code is a lot more flexible. Also, you are applying the single responsibility principle, which is in clean code somehow, that you can move the object creation code into one place in the program, making the code easier to support and make changes in the future. Also, open close principle is another principle in clean code, that you introduce new types of products into the program without breaking existing client code, which means Like the way I said in the previous example that we had different types of transport using ships, using trucks. If we want to add using planes, we are not going to make any changes in our client code. That code is working with the general transport class. But the thing that we are going to do is that we're going to make a plane class, or the transport using plane, that's going to have a different implementation in methods. So the general type is not going to change. So you're not going to make a lot of changes in your code. So it's going to be a lot easier to add this stuff. The only downside that it has, it's that you're gonna be making a lot of classes and subclasses, and it's gonna cause some complications, and it may cause your code to be a little bit hard to understand. But that's controllable. Like you can make sure that your code doesn't get hard to understand thing. You just have to use this solution in some certain places, not everywhere, and you need to use it carefully. And you can also apply this on an existing hierarchy that already has a creator class. So that's another way to use this. And in the end, it's gonna talk about relation with other patterns, but we're not gonna look at them because we don't know other patterns yet. And it also have a lot of examples in different language models and programming languages, so you can take a look at all those stuff as well. Thanks for watching, and if you found this content useful, please click like on this video, or subscribe for the future videos about design patterns. We also have a tutorial for Python. We also talk about clean code, some algorithms like sorting algorithms, that the videos are out already. More and more stuff are going to come. Keep the notification on, subscribe, leave a comment. I can use your feedbacks also. And thank you for watching the video. Have a nice time. Bye.